Hi, everybody. Let's do IXL pre-calculus F5 change of base formula. Except there's no question coming up. Okay, so remember, here's the change of base formula over here, and it looks complicated, but it's not really. So if we have the log to base c of some number a, then we would just put the a over here and the c over here, and we could say that this is equal to the log of a divided by the log of c to some base k, where k can be any non-negative number except for 0 and except for 1. All right, so let's look at the first problem over here. Rewrite as a quotient of two common logarithms. Write your answer in simplest form. Actually, I was doing this before. I don't think you really have to simplify any of these. So using the change of base formula, we can just write this as a fraction, where we have in the numerator the log of 37, and in the denominator the log of 8. And then the question is, what base are we going to use? And IXL for this problem is telling us to use a common logarithm, which means base 10. So we're going to put the log to base 10 over here of 37 over the log base 10 of 8. Oh, actually, I just realized it's giving me this log thing over here. So we don't really need to write base 10. If it's a common logarithm, then we can just write log, and that implies that it's base 10. Okay, so log of 37 over the log of 8. Okay, rewrite as a quotient of two base 7 logarithms. Okay, so we'll put the fraction thing here, and now we're going to do the log to base 7 of 45, which is this number here, over the log to base 7 of 2, which is this number over here. So you see, it's pretty simple. Just so in this problem, the a is 45, and we put that over here. The c is 2, and we put that over here. And then we're just basically using any other base except not the base that we want. IXL is telling us what base it wants us to use for this problem. Okay, so 7. All right, rewrite as a quotient of two common logarithms. Common logarithm means base 10, and we can just write that using just this normal log here, where we don't actually have to write the base in. If you don't write the base in, then that implies that it's base 10. So this would be the log of 3 over the log of 5. Rewrite as a quotient of two base 8 logarithms. Okay, hit the fraction thing again. Log to base 8 of 26 over the log to base 8 of 9. All right, so you can see that it's pretty simple. It's just telling you what base they want you to use, and then you would just put this number in the numerator and this number in the denominator, all right, to this base. If it says common logarithm, then that means base 10, or you could just use this thing over here. But I'm going to skip a level since these are all pretty repetitive. Okay, so now we see that it's not giving me a base over here. So what do I need to do for this problem? So I do know that it's telling me over here to use base 3 logarithms in my quotient. So let's do that. Log base 3. Here again, log base 3. I know that in the numerator here I should be putting a 9. What should I put in the denominator down here? So remember, if you do not see a base, then that means the base is 10. So down here we will be putting a 10. Okay. Two common logarithms, we're just going to use this one. So hit the fraction thing first. Log of 38 over the log of 4. Okay, 2 base 9 logarithms. And again, it didn't give me a base over here. So I'm going to do the log base 9 in the quotient like it said. And then I'll put a 6 over here in the numerator. In the denominator, since I was not given a base over here, and that implies the base is 10, that's a common logarithm over here on this side. So I'm going to put a 10 in the denominator over here. Okay. Right now it's giving me something different. It's telling me to use 2 natural logarithms. So natural logarithm means a log base e, but the abbreviation for that is just ln. Okay, log base e is written ln. That means natural log. So we're just going to write ln of 27, over the ln, or natural log, of 10. Where did I get the 10 from? Because again, looking back over here, the base was not written, so the base over here is 10. So this was a common logarithm over here. Here we're using natural logarithms in the numerator and the denominator. Okay, again, it's telling me to use 2 natural logarithms. So that means ln. So we'll put ln of 50 because I see a 50 over here. Ln of 10 down here because there's no base written over here, and that implies that the base is 10. So that, okay. All right. Okay, so we just did problems like that. Okay, rewrite as the quotient of 2 common logarithms. Okay, so over here we're going to be using common logarithms in the numerator and the denominator, so just log. Log of 39 over the log of what? So over here the base was not written, so you might be thinking that that's 10, but that would be incorrect because it says ln here instead of saying log. So ln means the log base e, log to base e. So we would be putting an e in the denominator over here. Okay, a quotient of 2 common logarithms. This is just like the last problem that we did. So again, I'll put common logarithms in the numerator and the denominator, just hitting this log. It's not telling me to do log base 5 or log base 8 or anything like that. So just hit the common log button. In the numerator, we're going to put 31, like this number here. In the denominator, we're going to put e, because the natural log of 31 means the log base e of 31. Okay, so whenever you see ln over here, then you're going to be putting an e in the denominator over here. Okay, I think we can jump ahead to the next level. This is again not giving me anything different, I don't think. So I'm going to jump ahead again. Okay, evaluate, round your answer to the nearest thousandth. So we're going to actually have to evaluate this, not just write log of something over the log of something. So we could use the change of base. I said in another video that if you're using the change of base formula, it's a good idea when you're choosing what you want k to be to pick a convenient number. Okay, so I would look at these numbers 44 and 6, and I would think 44 and 6 are both powers of what number? Okay, so for example, if I were to, let me just change this first. Let me change the problem. Instead of 44 and 6, what if I had, let's say, 16 and 8? I could ask myself, 16 and 8 are both powers of what number? And that would be 2. Okay, 16 is a power of 2 and 8 is also a power of 2. So if I choose 2 as my base over here, then I could evaluate this very easily. The log base 2 of 8 is 3, because 2 to the third power is 8. The log base 2 of 16 is 4, because 2 to the fourth power is 16. So I would get 4 over 3, which would be 1.3 repeating. So I could evaluate that pretty simply. The problem that we have over here is that I can't think of a number that 44 and 6 are both powers of. So we will have to use a calculator for this one, but we're still going to use the change of base formula. So we can rewrite the log base 6 of 44 as the log of 44 over the log of 6, and we can choose basically anything we want for the base over here, as long as it is not negative and not 0 and not 1. But since we are going to be using a calculator for this, if you just type log into the calculator, then it's going to do base 10. But that's fine, we could do base 10, okay, because it really doesn't matter what base we use. So I could write a 10 in here, okay, and choose that as my base, and that would work. All right, so I recommend going to desmos.com/scientific, and then we're just going to do, I'm going to click on function over here. Here's log. So we're going to do the log of 44, close the parentheses, and then go back here, divided by the log of 6. Right, and then enter. Okay, 2.11199, blah, blah, blah. So this says to round to the nearest thousandth. Okay, so here's the, after the decimal point, then we have the tenths place, the hundredths place, and then the thousandths place. So I have a 1 in the thousandths place. The next digit over tells me what to do with this 1. So if the next digit is a 0, 1, 2, 3, or 4, then this digit stays the same. If the next digit is a 5, 6, 7, 8, or 9, then this digit gets bumped up 1. This is a 9, so we're going to bump this up by 1, and that'll be a 2. So we're going to get 2.112 as our answer. Okay, we're just going to do this the same way. So we're just going to do, and actually you can just erase it in there. And then, see, that's kind of convenient. Just erase those. So to the nearest thousandth, this would be 0.431, because I see a 6 over here. So that 0 is going to get bumped up to a 1. So 0.431. Is it giving me anything different over here? No, I'll do one more and see if it gives me anything different for the next problem. So, and using the change of base formula, we could say that the log base 3 of 49 is just the log of 49 divided by the log of 3 to any base. And we're just going to use a base 10 here. When you just hit log into the calculator, then it's going to do base 10, but that's fine. Base 10 works. Okay, just about any base would work, except for negative numbers in 0 and 1. Okay, so 3.424, 3.542. Wow. Okay, it's getting a little bit late. 3.542 is going to be what this is, because the next digit is a 4, so this digit is going to stay the same. Okay. All right. Okay, and it looks like the rest are just like that. So I'm going to end the video there, and have a great day.